We now discuss the solution of a problem from the section Probability and Statistics. The question is related to the relations in combination with the probability. That is, the question is related to the relations clubbed with the probability. Right. This question has appeared in the Joint Entrance Examination Main held on 29th June 2022 in the second shift. The given question is the probability that a relation R from a set consisting of two elements x, y to itself is both symmetric and transitive is equal to. We are given four options. Option A, 5 by 16. Option B, 9 by 16. Option C, 11 by 16. Option D, 13 by 16. So, required to find the probability that a relation R from the set consisting of two elements x, y to itself is both symmetric and transitive. So that probability you have to find. Let's now discuss the solution of the problem in detail. Let capital A be the set consisting of the two elements x and y. Then A cross A, that is the Cartesian product of A with itself, is the set of all ordered pairs A, B, where A and B belongs to capital A. That is equal to the set of ordered pairs x, 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 y, y, x, y, y. We notice that the order of A cross A, n of A cross A, the number of elements present in A cross A is equal to 4. Agreed. Now let's recall what is a relation. A relation, capital R, from A to A, it is same as R is on A. A relation R on A is also called R, the relation R from A to A. It is a subset of A cross A. That is, a subset of A cross A is a relation on A. So how many relations are there? As many as there are the subsets of A cross A. Therefore, the number of relations on A is equal to the number of subsets of A cross A. That is equal to the number of elements present in the power set of A cross A. Power set of A cross A consists of all subsets of A cross A. N of the power set of A cross A, that is equal to 2 power n of A cross A. That is 2 power n of A cross A is 4. 2 power 4 is equal to 16. Agreed. Let S be the set of all relations on A. That is, S is the sample space in this context and n of S is 16. Agreed. So, let F be the set of the favorable cases. In our case, the favorable cases are F be the set of relations on A which are both symmetric and transitive. That will be the set consisting of the favorable cases. Right. The required probability is the probability that a relation R on A is both symmetric and transitive. That is the required probability is given by n of F. That is the number of favorable cases by the total number of cases. So n of F by n of S. Right. That is equal to n of F by 16. So we should know what is F. F is F consisting of the set of all those relations on A which are both symmetric and transitive. Right. So we will find out the capital F now. We have A cross A. Yes, given like this. And we want to enumerate all favorable cases. What are all favorable cases? That is, the relations on A which are both symmetric and transitive. So let's enumerate one after the other. 1. Phi. Phi is a subset of A cross A. Therefore, every subset of A cross A is a relation. Therefore, phi is a subset of every set and phi is a subset of A cross A. Therefore, phi is also a relation. And it is symmetric and transitive trivially. Great. Second, the relation, the singleton consisting of x comma x. Yes, it is symmetric. It is also transitive because transitivity is not failed here. Transitivity is also satisfied, trivially satisfied. So, this is the second one. So, the third one, so also in a similar fashion, y comma y. Great. So, now the question is, we want to find out relations with two elements. Let's say we have taken x comma x and we are looking for another ordered pair such that this is a relation, because it is a subset of A cross A relation. Is it symmetric and transitive? So we will fill up this blank. So first let me fill up with the x comma y. Yeah, this is possible. So now, is it symmetric and transitive? It is not symmetric. X comma y is there, y comma x is not there in this. Therefore, it's not symmetric. So, it is overruled. So, you take x comma x and look for another element. Let us say y comma x. And y comma x is there and symmetry is lost because x comma y is not there in it. So, therefore, it's not symmetric. Great. So, x comma x. Now, we add the other ordered pair y comma y. Yes, it is symmetric and transitive because transitivity is not failed. Right, trivially satisfied. Therefore, it is symmetric and transitive. So, this is a candidate for us. This is a candidate for us. So, arguing like this, now you can, so this is the argument. This is the argument. Agreed. Now, what about three elements? Relations with three elements? Relations with three elements which are both symmetric and transitive. Are there any? Let's say we take two elements x comma x, x comma y. We want to add one more element. So, we'll add y comma x. Symmetry has come, but the transitivity failed. How? Y comma x, x comma y will imply y comma y must be in it. Y comma x, x comma y together will give you y comma y if it is transitivity is there, but the transitivity is not there, y comma y. So, not transitive. So, x comma y, two elements, and I will add y comma y. Yeah, four elements. One element we have already tried. So, now symmetry is lost. Xy is there, but yx is not there. So, not symmetric. So, that means this all tells you with the three elements there are no relations which are both symmetric and transitive. And in this argument, what you are saying is, when you bring a third element, it says bring also the fourth element. Then it becomes symmetric and transitive. So that means with the three elements, there are no relations which are both symmetric and transitive. So the only possibility is the whole A cross A. A cross A is a subset of itself, therefore it's also a relation. So the only way is the whole of A cross A, that's a relation. This relation is not only symmetric and transitive, but it's also reflexive. It is a symmetrical, it is an equivalence relation in fact. So it is symmetric and transitive is there. So thus we have enumerated all those relations on A which are both symmetric and transitive. So what is our F? F is the set of favorable cases, that is the set of all those relations on A which are both symmetric and transitive. So these are the 5 elements which we have enumerated here. So what is n of F? N of F is 5. N of F is 5. Therefore, the required probability is n of F by n of S. N of F is 5. N of S is 16. So the required probability is 5 by 16. So let's look at our options. And our answer 5 by 16 appears against option A. Therefore, the answer to this question is option A. That is the detailed discussion of the solution of the problem from the section probability, and the question is related to the relations in combination with the probability, concept of probability. And it is definitely a good question, and not a difficult question, but it can be done. But one should have done this question before the examination in the classroom. Anyway, I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.